So I'm struggling to kind of come up with, what I think is the best way to tackle these, and I don't know that there is a best way. So you guys keep, developing your way of thinking about things, and I'll share some of the ways I look at these. I don't know that I have the best way or even a good way, but so we've got Matilda and Nancy, and we're told that they're 60 miles apart from each other. And they're bicycling towards each other on the same road. Matilda rides 12 miles per hour and Nancy rides 8 miles per hour. The question is, in how many hours will they meet? So, I'm going to start by writing a let statement to help clarify something that's going on here. So I'm going to say, let's let, I'll go with M. I'll let M be, not equal, I'll say, let M be the distance, and it would have to be distance in miles that Matilda travels. And by the way, when you make let statements, it should always include both, what the quantity is and the units for that quantity. So we're also going to let N be the distance in miles that Nancy travels. And if I look at this, I'm told that they start out being 60 miles apart. This might be helpful. And I don't know who's traveling more, right? I don't know who travels further, but I think it's safe to say that the distance that Matilda travels plus the distance that Nancy travels has to add up to 60, right? Because they're trying to close this 60-mile gap. One of them is going to travel some of it, the other is going to travel the rest of it. So I would say M plus N has to be 60. And the other equation I have probably comes from the fact that distance equals rate times time. Let me try this. So I know that for any of these settings, right, the distance traveled equals the rate that you're traveling at times the amount of time that you're traveling at that rate. So I could say the distance that Matilda travels, which is M, right? The distance Matilda travels is equal to her rate of, what is her rate? Matilda rides 12 miles per hour. 12 miles per hour. And I can also say that the distance Nancy travels, because her rate is 8 miles per hour, so it's 8 times t. So this is not feeling like a system to me, but I do have, I guess it's kind of a system, but it ends up with 3 equations. I don't know if I need all 3. But what's nice is I do definitely have an M. Actually, I do have 3 variables here and 3 equations. Didn't intend this to happen, sorry. But this is true. I definitely know that M plus N equals 60 miles. I could see that from my original diagram, right? The distance that Matilda travels plus the distance that Nancy travels is 60 miles. And also, right, because this is a valid substitution for Matilda's distance traveled, and this is a valid substitution for the distance that Matilda travels. So if I plug those in for Nancy, or I said Matilda, Nancy and Matilda, if I plug those in, I get this new equation that only contains t. So I could say that 12 times t plus 8 times t equals 60 miles. 12 and 8 is 20, so 20 t equals 60, therefore t has to be 3 hours. So it looks like they'll be near each other in 3 hours. And I can also answer questions like, well, how far did Matilda travel and how far did Nancy travel, right? So I take 12 times 3, that's 36. So I know that Matilda traveled 36 of the miles, and then 3 times 8 is, what is 3 times 8? That's 24. Nancy traveled 24. So this diagram was not drawn to scale, but when I do add those up, I do get 60. So they're going to meet each other in 3 hours, and I hope it's lunchtime.